Good day. Now we are doing question number 5. This question paper, that is September 2023. Okay. This is on work, energy and power. A crate of mass 50 kgs is at rest at point A. Now the crate here is at rest, meaning that the velocity is 0, which is at a vertical height of 5. So we have this height, which is 5 above the horizontal surface. The inclined surface makes an angle theta, so we have that theta to the horizontal with the horizontal as shown in the diagram. When the crate is released, it slides down an incline and reaches B. To be at the bottom of an incline with speed, which means the speed here of this object is 8 meters per second. So the speed at the bottom, that is at B, the speed at B. The incline exerts a frictional force, so we're given a frictional force of 72 newtons on the crate while it slides down from A to B. Okay, now we have two paths. We have AB and BC, which means we are going to have two free body diagrams. We have a free body diagram on path AB and a free body diagram on BC. Let's just go straight to the questions. The first question says, state the work energy theorem in words. The work energy theorem in words states that when the net force acts on an object, no, it's not like that. It says the net work done on an object is equal to the change in object's kinetic energy. The net work done on an object is equal to the change in object's kinetic energy. The following question says, calculate or use the energy principles to calculate the angle theta. We want theta. Okay, so to answer this question, you must first draw the free body diagram of the incline. So here we have this object. There is a normal force on this object. There is Fg. Then there is a friction, that is Fk. That is the free body diagram we have. Okay, so the free body diagram, we're about to answer 5.2. Let's start with the free body diagram of the inclined path. So we have that normal force, then we have Fk, then we have Fg. Now we must remove this one because it's always perpendicular. It does a 0 work. So we are left with friction and Fg in this case. And if we can look at Fg, the displacement for Fg, in fact Fg is parallel to the height, which means delta x for Fg is 5. But we don't know delta x for what? For the friction. Okay, now let's just use the principles and see what we'll get. Let's go. If I can draw the path here, we are looking for theta. We have the height, which is 5. To get theta, we need this side, which is delta x. Therefore, the focus is on delta x. so that we are going to use trig ratios to get theta. Okay, so we have two forces. Therefore, work net is equal to change in EK. Then the net work done is the work done by frictional force plus work done by Fg, which is equal to change in EK. The change in EK is 1 over 2 mvf square minus 1 over 2 mvi square. Now the frictional force, the work done by frictional force will be frictional force times delta x, which is parallel to frictional force, times cos theta, plus for Fg it's Fg times delta x, which is parallel to Fg, times cos theta, which is equal to 1 over 2 mvf square minus 1 over 2 mvi square. So the friction was given up there. Let's check the friction. The friction is 72, as you can see. So the friction on that path is 72. So we have 72, that is the friction. But we do not have the displacement that is parallel to the friction. So that is our delta x. Then cos the angle for friction, always just put 180. Then Fg. Then Fg is mg, is equal to mg. Then the mass of this object is 50. So the mass is 50. Times. Then g is 9,8. Then the displacement for Fg is parallel to this 5, which is the height. Therefore, since Fg is going down, the height is going down. Therefore, that is delta x. So we have that 5 cos the angle, since the object is going down, therefore the angle theta should be 0, because the object is going down and the displacement is going down, so is 0. So it's down, down. So the angle there should be 0, which is equal to 1 over 2 times the mass is 50 times the final velocity, that is the velocity at B, is 8 meters per second. Then it was released, so we have 8 meters minus 1 over 2 times the mass, which is 50. It was released from rest, so that is 0. Then let's press calculator here. We have here 1600. Then here let's press calculator, then we get 2450. Then here when we press calculator we get minus 72 delta x. Then let's transpose this one, it will become so 1600 minus 2450. Then we get minus, so we have negative 72 delta x, which is equal to minus 850. Then we divide by 72, negative 72, negative 72, divide by negative 72. Then we get delta x, which is equal to 11,80 meters, which means this one is 11,80 meters and this one is 5. So this one is opposite, which means we can use the sine ratio. Sine theta is equal to opposite over hypotenuse. So sine theta is equal, the opposite to this angle we are looking for is 5 over 11,8. Then theta is sine inverse of 5 over 11,8. Therefore theta is equal to sine inverse 5 over 11,8. Then theta is 25,07 degrees. That is angle theta that we're looking for. That is theta. Then you get 6 marks for that. Okay. The following question says, after passing B, the crate slide along a rough horizontal surface. So the surface is rough, come to rest at C. So at C, the crate is having the velocity, which is 0 meters per second. Let's continue with the question statement, which is 10 meters away from B. This becomes the initial velocity. This one is the final velocity. Calculate the work done by the frictional force to bring the crate to rest. Now let's work on that. Let's draw the free body diagram first. Or the question said, draw the free body diagram. If the crate is here, we have the normal force, we have the weight, that is Fg, then we have the friction. There is no other force there. That is 5.3. 5.3. We have the normal force, we have Fg, then we have Fk. Now if you can look here, okay, let's go to 5.4, which says calculate the work done by friction. 5.4, work done by friction. Calculate the work done by frictional force to bring this crate to the rest. So if you can look here, this one and this one will have a 0 work. This one will have a 0 work because they are perpendicular to the displacement, which means we are left with this one. Therefore, work net is equal to change in EK. Okay. So the force that we have now is friction, which means we have work done by friction, which is equal to 1 over 2 mv F square minus 1 over 2 mv I square. Okay. And then we are looking for work done by friction. We have 1 over 2 times the mass, is that 50, times the final velocity, that is velocity at C is 0, minus 1 over 2 times the mass, is that 50, times the velocity, initial velocity, that is the velocity, the initial velocity of this path is the velocity at B, which is 8, which is 8 square. Okay, then we get 0 here, here is 0, then we get work done by friction, which is equal to negative, then we press calculator, 0.5 times 50 times 8 square, then we have 1600 joules. That negative tells that the system, the crate loses energy. So this is a scalar quantity, which means we have no direction. Then we are done with this question. Let's go to question number 6. Question number 6.